All right, law of sines and area of a triangle. Notice that we didn't say anything here about a right triangle, so we are no longer having to deal with right triangles. All right, so those tools that we had yesterday were only tools that we used on the right triangle type problems. Let me find it really quick. Notice the title yesterday was right triangle trig. So these tools here are used for what special type of triangles? Right triangles. This new law that we're learning today, law of sines, can be used on any triangle. Now, when you're doing like opposite over adjacent and opposite over hypotenuse, that type of stuff is only for right triangles. But law of sines is a little different. So let me show you how to do it. First off, the formula looks like this. Let's just write it down and I'll explain. Sine of A over little a, and little a stands for side A, equals sine of B over little b equals sine of C over little c. All right, so sine of an angle. Now you're not going to use all three at one time. I just don't want to write all the different possibilities. So I'm going to cover that, and I will lift up my hand in a second. Sine of one angle over its opposite side will always equal sine of a different angle over its opposite side. Now it could be A and B and B, or you could do sine A over sine A equals sine C over side C, or B and C. Does it matter which combination you use? No. Will you ever be using all three at one time? No. Any two. A and B and C, A and C. All right, questions before I actually give you a problem and we take a look at how this works. Okay, now we talked yesterday about what it means to solve the triangle, yes? Yes? All right, we're going to do it the same way we did before. I'm going to give you, for number one, I'm going to give you that A is 35 degrees, angle B is 62 degrees, and little a is 15. Okay, we're ready? So remember what I said about drawing your triangle. Now I'm not making a right triangle this time because it's not a right triangle. Oh, at least we don't know that it is. Actually, we do already. We can tell from these two angles that it is not. AB, C. All right, I'm going to write down the given information. Angle A is 35. Angle B is 62. We don't know angle C, but it's going to be easy to find. Little a is 15. And what would I call this side right here? Little c or little b? Little b. And this side right here is little c, because it's opposite angle C. All right. Over here I'm going to write down angle A equals angle B, just like we did before, angle C, and then little a, little b, little c. All right, what is given? Angle A is 35 degrees, angle B is 62, and little a is 15. All right, can I find angle, oh, is angle C 90 like on the other lessons? No, not, it could be, but it's not an assumed fact because it's not a right triangle. But the one tool that we can still use is that all angles add up to what? 180. So 35 plus 62 plus angle C equals 180. Go ahead and solve that now. Add and subtract. And tell me when you have it. 83. All right, that is our first unknown that we have found. Yes? Question? Okay, I'm going to find B first just because. Now, if I am looking for little b, what angle am I going to be using on the numerator? Sine of b. So if I'm looking for little b, I need to know angle B. So let's go to little b. Do I know angle B? Okay, so that I'm going to set that up. Sine of 62 over the unknown b, that is what I'm looking for, equals. Now the next triangle cannot have any variables because you can only deal with one variable at a time. So would it make sense to use angle C? Does it make sense to say sine of 83 over C? No, because then I have too many variables. So I'm forced to use which fraction for my second one? Sine of A, which is sine of 35 over 15. Why am I forced to use that one? Because it's the only one that has no variable, no unknowns. Do you see that? All right, so one of these will always be an angle and a side that you know. Do you see that? I know angle A, I know side A. That will always happen when you're using law of sines. You know an angle and its corresponding side for at least one of them in your triangle. All right, and we're just going to cross multiply. What do we have here? 15 times sine of 62 degrees equals B times what? Sine of 35. Before we plug in our calculator, what do we divide both sides by? Sine of 35. Is this something you can plug in your calculator all in one shot? You can just type in that times that, divide, but the one thing you want to make sure is you do what with the 62 before you hit divide? Close the parentheses, good, because it's going to give it to you like this. Close it before you hit divide. All right, plug it in now. 15 sine 62, close parentheses, divide sine 35. And then hit equals. And don't forget your 3 decimal places. And what do we get? B is, anybody have it? 23? 0.091? Okay, 23.091. Any questions? All right, I'm going to have you do now on your own how to find side C. I'm going to label this as 83, and you go ahead and do the work for the second part. Do it quickly. Don't sit there waiting for me is what I mean. Okay, John, give me your equation that you're going to set up to find side C. I'm ready. Sine of 83 over C, good job, equals perfect over what? 15. Good. Now, if he wanted to, could he have used sine of 62 over 23.091? Yes, because we know now angle B and side B. But why would we not want to use that combination? Decimals, we'd rather not. Less work, less plugging in. All right, thank you for this one. And then you do the same thing. 15 times sine 83 equals C times sine of 35. And then you divide both sides by sine of 35. Don't forget to close your parentheses there before you hit divide. Go ahead and plug it in. And it also starts with the 2. All right, what do we have? 25.957. All right, questions before I move on? Does it seem doable? All right, so this is a new tool we now have, law of sines. Next one, A is 38 degrees, little a is 17, and little b is 13. When you're using law of sines, like I stated earlier, you will always need to know an angle and its corresponding side. Here it was angle A, side A. What is it here? Is it the same thing? Angle A, side A? Will it always have to be A with A? No. If they gave you angle B, side B, would that be okay? Yes, but there will always be you will always need one set given in order to use the law of sines. Okay, let's draw our picture. Again, it's not a right triangle. A, B, C. A is 38 degrees. Little a is 17. Little b is 13. And what is this side over here called? Little c. All right. Angle A, angle B, angle C, blank, 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 little a, little b, little c, blank, blank, and blank. And let's fill in what we have. Can I use Pythagorean's theorem to find side C? I cannot. Kids will say, well, you have enough. A squared plus b squared equals c squared. Why not? It's not a right triangle. Good. At least we don't know enough to know it is. And it's not stated that it is a right triangle. All right. So we cannot. Looking even here, this helps to have this set up. Can I find, what do I have to find first? I'll start there. What's the first thing I have to find? Why is angle B the first thing I have to find? Because do I have enough down here to find anything for C? No, because I have too many unknowns. How many unknowns can you have at one time when you're solving? 1. And how many unknowns do I have here for C? 2. An angle and its side. So I'm forced to find what first? B. So sine of B, I don't know, so I'm going to leave it as B, over little b, which is 13, equals sine of what over what? Sine of 38 over 17. Now I'm going to set it up the same way by cross multiplying. I'm going to stop here. What is the unknown, a side or an angle? What does that mean when I actually plug it in my calculator? I'm going to be using the inverse key. So let's see how that's going to work here. I'm going to cross multiply. I'm going to have 17 times sine of B equals 13 times sine of 38. All right, now if I'm looking for B and B is attached to the sine, kids often say, oh, divide by sine of B. No, what am I dividing by? 17. So I am left with inverse sine, I'm not using inverse yet, sorry. I'm left with sine of B equals 13 sine 38 over 17. Now, I just said it a second ago, what does it mean if you're looking for an angle? Inverse. So you're going to type it in like this. Inverse sine of 13 sine 38 divided by 17. What do you have to make sure you do right here before hitting divide by 17? You have to make sure you do what? Close that parentheses. All right, so type that in. Inverse sine 13 times sine of 38, close that set of parentheses inside, divided by 17. Now there is another parentheses to close. If you close or don't close, it doesn't really matter for that big one out there. Equals, and you just found your angle B. All right, and so what is angle B? 0.86. And now do you have enough to, you do have enough to find which piece? Third angle. Can you guys find that quickly? Add, subtract from 180. All right, so we saw one really quick, one where we're looking for sides because we know all our angles, and one where we have to find the angle. And don't forget, when you're looking for an angle, you use your inverse key. And anybody find it? What was it? 113.914? Okay, because of time, I'm not going to finish this one off, but I will at least set it up for you guys. Can you tell me what it would look like when I'm looking for side C? Sine of, I'm looking for side C, so sine of what? 0.914 over little c equals, and I've run out of room, equals what? Sine of 38 over 17. And if you wanted to use B, you could, but I definitely did not have the room. All right, I'm going to stop there only because of time. I will give you the answer, so when you work it out later, it is 25.242, but I do have one last problem to do with you. If you did anybody work it out? Did anybody work ahead of me and work it out already? Yes? All right, I'm going to flip the page, but before I go on, does it make sense? Yes? All right. Area problem. Area of a triangle equals. Now, the triangle formula you learned, what was it, half base times height? Is that the one you learned way back in like middle school? Okay. A different one, it equals 1/2 side B times side C times sine of A. Or it could also be written like this, 1/2 side A times side B times sine of C. Or there's one last one, but I want you to look at the pattern. Sine A, but no side A, it's just sides B and C. Sine of C, but no side C, it's just sides A and B. So the last one's going to be sine of what? I've done AC, this would be sine of B, and what would be my sides here? AC. All right, now kids are like, oh, that's a lot to memorize. Just memorize one. It's always going to be sine of an angle times whatever two sides here are not corresponding with that angle. Make sense? Another little note that you should know, this is used when it looks like a side angle side problem, when it's an angle sandwiched between two sides. Let me show you what I mean. Find the area if little a is 16, little b is 20, and these are all centimeters, and angle C is 84.5 degrees. All right, so little a is 16 centimeters, little b is 20 centimeters, and angle C is 84.5 degrees. I would suggest you draw your triangle again. It does not matter where you put your A, B, C. There's no right angle in this one. I'm going to label angle C as 84.5. Little a is 16. It's opposite angle A. Little b is 20. It's opposite angle B. Do you see what I'm talking about with side angle side? Yeah? Side angle side. All right, so if you maybe think, well, I didn't need the picture to work it out, but I just want to make sure when you see this, you know your area is going to be 1/2. I work at the angle first. What is the sandwich to angle I'm dealing with? C. So sine of C. And what two sides would I have here if I'm dealing with angle C? Sides A and C or A and B? A and B, because that's the way the formula works. So do I know sides A and B? 1/2 16 times what? Times sine of, do we know angle C? 84.5. And that's what I want you to plug in your calculator right now. You can use 1/2 using your fraction key, or 0.5 times 16 times 20 times sine of 84.5. Plug it into your calculator right now. It should end up in the hundreds. Anybody have it?
159.263.
Thank you. And it's centimeters squared, because that's what area is, units squared. Make sense? We will learn another area formula eventually, so you will need to know them for the test. Questions?